what we're going to be going over here is solving for multiple product cost, volume, profit here in units or quantities here. So we're going to have to determine the units or the quantity here that's going to be needed for some targeted net income here before taxes and net income here after taxes. All right, and we're going to be doing that for multiple products here. So for our CVP basic concept, this is where our total revenues equal our total cost plus some profit here. So TR here, total revenues, equals TC here, our total cost, and then the profit would be looking at some net income here before taxes or net income after taxes. So you'd have some targeted dollars here in your targeted net income that you'd be looking at here. Okay, so we can further look at it here where TR, total revenues, equaled our total fixed cost plus our total variable cost. That's the total cost here, plus the net income here before taxes in this case. So we can rearrange this equation just by moving our total variable cost over to the other side of the equation. So our total revenues less, or the difference here between our total revenues and our total variable cost, equals our total fixed cost plus our profit here, net income before taxes. So this total revenues versus our total variable cost, that represents our total contribution margin here. Okay, so total contribution margin equals our total fixed cost plus net income here before taxes. So now we can go through and we'll look at our calculations, and we'll be going through a problem here. We're looking at it and have our equations here, and then we'll apply it to some numbers here. So our total revenues is going to equal our total fixed cost plus our total variable cost plus some targeted net income here. So our total revenues, that's really the unit price here times some quantity, and that's going to equal our total fixed cost plus our total variable cost is going to be some unit variable cost here on a per unit basis times some quantity. Again, plus our net income here before taxes. So we can move our total variable cost over to this side of the equation. So we got price times some quantity here equals less the variable cost times some quantity here equals our total fixed cost, and then we can factor out that quantity that we're looking at here from between our price and our variable cost here. So price, unit price, less our variable unit cost here times that quantity equals our total fixed cost plus our targeted income that we're looking at here. So we can further break it down here when we're working with these multiple products. This contribution here, difference on a weighted our contribution margin here, price versus your variable cost, that's going to represent our W. That's going to be our weighted average contribution margin on a per unit basis. So that weighted average contribution margin times some quantity here equals our total fixed cost plus our profit that we're looking at here. So when you're dealing with these multiple products, you're going to have to lay them out here in table form here, where you're going to have your different products. In this case, we're only going to be looking at 2 of them for this example, but you have any number of those different products. So I'm going to have a product X1 here and product X2, and then you're going to have a unit price for each of those products. And then you're going to have to know the unit variable cost for each of those products. And then the other important item here is what they call this mix ratio. That's how much you sell of each one of these different products here. So in this case of X1, we're going to be selling 75% of our sales are going to be for X1, so the mix ratio is 0.75 here. Everything's based on 100% here. And then for product X2, mix ratio is going to be 25%. So we sell 25% of our sales are for product X2 here. So that's going to give a mix ratio of 0.25. So now we have to determine our weighted average contribution margin that we have up here. And that's simply summing here. I got this E here equals the sum of, or the sigma here. And that's the difference between your unit price here and your unit variable cost times that mix ratio here. Okay, so this is our general solution here with this equation here. So let's calculate our weighted average contribution margin. So this is the case where you're going to take your price versus your variable cost. So looking at product X1, that would be a price of $4 here, variable cost $3 per unit. That difference here times the mix ratio here of 75%. Okay, or 0.75 here. Then we add to it. That's what we talked about, the sigma here. We add to it what our product X2 here. That's unit price of $8 less our variable cost here of $5. That difference times the mix ratio here of 0.25 or 25%. Total everything up here, and you're going to get the W here. Our weighted average contribution margin is 1.5. Just a matter of summing our different products together here, looking at the individual contribution margin, price less our variable cost times that mix ratio. Okay, so we got our W here, weighted average contribution margin on a per unit basis here of 1.5. So our total contribution is going to be X number of units here. Those will be the total mixed units, as we call them here. So W times 1.5 here. W is 1.5 times X units here equals our total contribution margin here. W times X. Okay, so first for our break-even point here. And what we do here for our break-even, this is where we're looking at that total contribution equals our total fixed cost plus our net income here before taxes. But for break-even, our net income here before taxes is just set at the 0. So it'll be our total contribution here, WX, equals our total fixed cost. And you can look at it in these terms here. When we talked about that contribution, that was our price versus our variable cost on a per unit basis times X equals our total fixed cost plus net income here before taxes. So price versus our variable cost just represents our contribution here on a total, our contribution here on a per unit basis. That's what we calculated, that average contribution here for our average between those different products we have. Price versus variable cost here times the number of units that we have to solve for here equals our total fixed cost plus net income here before taxes. Just solve for that here. Divide to solve for X here, you just divide both sides here by W. So you're going to get your total fixed cost plus net income here before taxes divided by W, the weighted average contribution margin here on a per unit basis. Okay, so what we would do here, just going back to our solution here, our W here was 1.5, X was the number of units here. Our total fixed cost was 300,000 in this case, no net income here. So we're just covering our fixed cost here. So the break-even point here with no income here is just for the quantity here, you just divide both sides by 1.5, and what do you get? X is going to equal 300,000 divided by 1.5. That equals 200,000 here. Those are the total mixed units that we're solving for. So 1.5 was, remember that weighted average contribution margin here on a per unit basis. Just divide that into 300,000. That gave you the number of units here. The total mixed units is 200,000. So now we have to proportion out these total mixed units amongst product X1 and product X2. In this case, we're only dealing with two different products. So we take our total mixed units, 200,000, times the mix ratio, our ratio here, a mix ratio. For X1, it was 0.75 or 75%. So X1 here, product X1, we're going to allocate 150,000 units here to product X1. And then X2 is just take that total mix amount here, 200,000 times its ratio here of 0.25 or 25%. So we allocate 50,000 units here to product X2 here. Okay, so that's our break-even point. We got to sell at least 150,000 of X1 and 50,000 here of X2 in order to break even here. So you see what's going on here. First, we had to take that individual contribution margin here and times the total number of units that we have here. And then we had to determine that total number of mixed units here. That X here represents X1 and X2 here. We had to divide by that average contribution margin here method. And then we came up with, then we determined our total mix. And then after our total mixed units, the total number of units, we proportioned them out using our mix ratio here, taking the total number of units times the mix ratio allocated for each product. That determined the number of units here for break-even for X1 here, and then same for X2 here. Okay, so that's for our break-even point. Now let's go and let's solve up here. Let's say to earn 60,000 here in net income here before taxes. We're going to go through the same situation here. In what we're going to do, same equation here, only that for instead of our net income here where we set it equal to 0 for our break-even point, we're just going to put 60,000 in here. So our total fixed cost was at 300,000. add to it our net targeted net income here before our taxes is 60,000 here. And then the WX, remember that was at 1.5, that was the weighted average contribution times the number of units here. So we could just, before we go through our calculations here, just to understand this equation, get familiar with it, that W here was just the difference between our unit price and our unit variable cost. That's our weighted average contribution on a per unit basis here, times the number of units that we're solving for, the total number of units here. That equals our total fixed cost. In this case, our net income here before taxes, we got a targeted amount here of 60,000. So just solving for X here, W equals P less our V price versus our variable cost here times the number of X total mixed units here. And then just solving for X, just divide both sides here by W. So you get X number of units equals our total fixed cost plus net income here before taxes. Weighted average contribution margin W here. So just going back to our general problem here, that 1.5 W times the X number of units equals 360,000. So X, just divide 1.5 into 360,000. That's going to give us 240,000 of mixed units here. So now to allocate those 240,000 mixed units between product X1 and X2, you just take the total mixed units here, 240,000 times each of that mix ratio here. X1 was 75.75 or 75%. So that's going to give us 180,000 units here for X1. And for X2, that was a mix ratio here at 25% times 240,000 to total mixed units here. That's going to give us 60,000 here units of X2. So to earn 60,000 here in net income before taxes, we're going to have to sell 180,000 here units of X1, and X2 we're going to have to sell 60,000 units here. Okay, so you can see what's going on here. Just take your total. You have to first solve for your total mixed units. When you have the targeted net, you have to have some targeted net income here before tax plus our fixed cost based on our equation, and then we solve for our mixed units, and then to solve for allocate them between the two different products here, we just took the mix ratio times those total number of mixed units that we solve for here to allocate them here. All right, so that's what we've done here for our second case here to earn 60,000 of net income here before taxes. Okay, so now let's look at to earn 36,000 here of net income here after taxes. So what you're going to do here, you're going to have to come up with your relationship here between net income before taxes and net income here after taxes. So net income here after taxes is just going to be 1 minus the tax rate times the net income here before taxes. So that's our relationship, your net income here after taxes. So we can solve for, we're going to have to plug this net income here after taxes into our equation and substitute it in for net income before taxes. But to solve for our net income here before taxes, that's just going to be net income here after taxes, and you divide both sides here by 1 minus the tax rate here. So net income before taxes equals net income here after taxes divided by 1 minus the tax rate. So if we're saying our tax rate, let's just use for this example here is 40%. 1 minus our tax rate is going to be 60%. So if we just solve for the total mixed units here, we could go back and total X here is going to be our total fixed cost plus, in this case, net income here before taxes. We substitute a net income here after taxes versus divided by 1 minus the tax rate here. And then you just divide it by the weighted average contribution margin per unit here, W here. So that would be your general solution here to determine X. So let's go back and we'll plug that into our problem here. So WX here equals our total, that's our total contribution margin, W here, X, equals our total fixed cost, plus in this case the net income here after taxes divided by 1 minus the tax rate here. That was we substituted net income here before taxes based on net income here after taxes divided by 1 minus the tax rate here. Okay, so just going on here, 1.5 weighted average contribution here times number of units that we're solving for equals our total fixed cost 300,000 plus our 36,000 here net income after taxes divided by that 60% here, or 0.6 here. So that's going to give us 1.5x equals 300,000 plus 60,000 here. So solving for x, just divide both sides by 1.5 here. 360,000 divided by 1.5, again, gives us 240,000 here of mixed units. That's the total number of x, and 1 here and x2 here. So again, just solving for x1 here, you're going to take, and x2, you just take those total mixed units that you're looking at. In this case, again, taking our mix ratio here, 75.75 or 75% for x1 gives us 180,000 units, and then x2 gets 25% of that, the total mixed quantity here, 240,000. That gives us 60,000 units. So again, to earn 36,000 here of net income here after taxes, we just had to determine the total number of mixed units here, and then we had to allocate it based on that mix ratio between x1 and x2 here. But the key point is here, just putting it into our equation, you have to understand your net income here before taxes, the relation to that versus your net income here after taxes. And that's just taking net income here after taxes is 1 minus the tax rate times net income here before taxes. And then you can solve for net income here before taxes just by dividing both sides by 1 minus the tax rate. You can plug it into your equation here, that generalized equation that we have here. Or you can go back, and that's what we've done here to make our solutions here. Just understand that relationship. Okay, so that's our general understanding here for when you're dealing with multiple products here. All right, so we went through the problem here and we applied it to our general equations here. And just one last thing here. Just showing the key here for this particular problem. I don't have all the key of all the references here, but I here, little I here, represent the number of a particular product. PI here, that was unit price of a product here. A unit price of product I here. VI would have been a unit variable cost of product I. X was the total mixed units that we have to sell. XI would be the units of a product I that would be sold. MI would be the mix ratio of product I, a product I that was sold. And then E here represented just the sigma here, or the sum of the total here. W was the weighted average contribution, that margin per unit. That was sigma here times the difference between unit price and unit variable cost times the mix ratio. And then Y, we didn't use this here, but that would be a weighted average price. Again, the summation here of your unit price times your mix ratio. Okay, so we went through a problem here solving for multiple products at CVP analysis here. Just remember, you have to come up with your mix ratio here, and you have to know a unit price, unit variable cost, and then you'd have to be able to know your mix ratio here for your various products, and then you can do your allocation to determine how you solve for your different quantities here based on your mix ratio here and your weighted average contribution margin between the different products. All right, so that'll end our discussion.